So, so this is an example. Can you see my cursor moving over the greater than sign?
Yes.
So we're not trying to prove that one number is either equal 11 or not equal to 11, which is how the other maybe example one was. Now you're trying to prove that it's bigger than a number, or sometimes less than a number. In other words, that's called a direction. It goes by various names. It's called a directional test because you have a particular direction in mind. And sometimes it's called a one-tailed test because you only use one side of the rejection region. It's not on both sides. Okay, so that's just the theory behind it. And the other thing you need to know is some examples in these chapters you go to the Z, and some examples you go to the T. And the reason, and most of the time you go to the T because you're given what's called the sample standard deviation, or just a standard deviation based on that sample. It's not based on the whole population. When you have the whole population, which is very rare, then you can go to the Z. Most of the time you go to the T. So the first question, what is the standard error of the mean? I'm not sure StatCrunch will help you with that, even though it probably could.
I think StatCrunch gives you the standard error.
Oh, it does? Okay, good. So you know that. That's good. So that gives you, basically, you take the standard deviation and divide it by the square root of the sample size. So it's like square root of 25 is 5. So 5 into 2.3 goes about a little bit less than half, like 0.43 or something like that. Okay. What is the critical value of T for 95% confidence? This, again, it involves some understanding, but StatCrunch will give you that. I'll show you how to do that in a second. StatCrunch will easily give you the third one, and it involves some interpretation. All right, so let's start at the beginning. I'm going to go to StatCrunch, get more help. StatCrunch. That's the first step. Okay, now I have to remember the question, of course, which okay, so you want the critical value. So yes, you have to go to stat, and then you have to go to calculator. Of course, that's basically you're looking at, I don't know how usually you look it up at a table but using StatCrunch, you go to what's called calculator, and you move down to the T. Okay, because we're dealing with a T problem. Okay. And then you get the following picture. And here's where knowledge is helpful. To get the T, you need to know two things. Well, you need to know that it's a T, and you know that because it gives you the sample standard deviation, which is very common. Secondly, for T, you need what's called the degrees of freedom. DF stands for degrees of freedom, which is always the sample size minus 1, at least in chapter 13 of this. So it's 24.
Okay.
Now, then they're telling you make a 95% confidence interval. Here where I'm not even 100% sure myself, because you see, when you usually confidence intervals are on two sides.
Mm-hmm.
Of course, we're dealing with just greater than as opposed to not equal. We only focus on one side. Where's that picture again? There's a picture here. Let me try again. Stat, calculator, T. Okay, there it is. Well, if I move it, I lose the picture. Okay. So we put in 10 degrees of freedom. I'm sorry, it should be 24. That's when we lose the
I think because you have to put another value, and then it'll pop up.
calculator. We'll put that in the light. I just want you to see the picture. That's why I want you to. Okay. So usually you want a boundary on one side and a boundary on the other side so that you have a like 95% in the middle when it's on two sides. You know what? Okay. What I'm struggling with is when there's something called a one-sided confidence interval. But I don't think the book wants you to do that. I think they just want you to do a two-sided confidence interval. Let's do that. So if 95% is in the middle, that means each piece has to be 2.5%, 2.5% over here and 2.5% over here. So we want to figure out which t-value cuts off, 2.5%. We want the red to be 97. So we want the red to be, we're looking for that. It's going to be 97.5.975. 2.5, that's missing 2.5% on one side. And automatically is 2.5% on the other side, but we'll put 24 in here. I'm not explaining well. I realize that. Let me try it again. I want to make sure it's right. 2.06.
But why'd you put 0.975?
They want a 95% confidence interval, which means that, by the way, I do explain this even better in some of the videos for these chapters. You go to the chapters.
On your YouTube?
What do you say?
On your YouTube?
On my YouTube, yeah, it might be useful to do that, but I'll try to explain it now. I know I'm not explaining it well. I want to make sure that it's right before I start explaining it. So 2.06, let me just see. You know the answer to the first one? How much is 2.3 divided by 5? 0.4 something. Do you have that? You have a calculator?
Yeah, I'm getting it right now. You said 2.3 divided by what?
So 0.3 divided by the square root of 25, which is 5.
0.446.
Or 2?
0.46.
46. Okay.
Yeah.
Move on to the next question. The critical value for T star. So my only question is it one-sided or two-sided? 0.063, we're rounded to 2.064. I would go back and explain. What's happening is that a 95% confidence interval. I mean, again, I can't explain this in 3 minutes. It's really like a 1 hour lecture, or that the YouTube would be useful. But basically, the formula for a confidence interval. We go back to view an example. Let's do that. Okay, so this is about view an example, right? You've seen that?
Yeah.
Okay. So the first they tell you the formula I just mentioned. Okay, that's that. Critical value, confidence level, and number of degrees of freedom. Okay, remember the degrees of freedom is the sample size minus 1. In this case, the sample size was 81. We know that. We say find the 90% confidence interval.
So, okay.
No, okay, well, they're not explaining how to do it. You really need let's go back to our problem. I'm going to erase this because I wanted to see if they explained it any better than what I was doing. So let me go back to me again. Okay, so basically, what you want whatever the degree of confidence is going to be the piece in the middle. Okay, in other words, in this case, you see where the 2 starts out at like a little red. The red ends at the 2.
Yeah.
Okay, but unfortunately, they're not really giving you. Oh, you know what? We could do between. Sorry, it would work out between. Okay, you want the piece in the middle to be. In this case, we want it to be. That's going to be 1. Equals. We want the people. What is 95%? 0.95. Well, I didn't realize it might work. Yes, there it is. Oh, it's even easier than I thought. There's 2 options. like the normal distribution we had in chapter 7, is either between or standard. Right now we're doing between. We want the piece in the middle to contain 5% because that's the 95%.
Mm-hmm.
85% of the time is where the number is going to be. So you got to know the degree of freedom formula, n-1, that's easy. And then you put down blank and blank, and you put down the degree of confidence, 0.95. You hit compute and you get the answer. So that 2.0639 or 2.064 is the right answer.
Okay.
That's easy, right? Now
Yeah.
find the actual confidence interval. To do that, again, you do that in StatCrunch. You can use a formula if you want, but you might as well use StatCrunch. You go to T-stats. We have one sample because in the next chapter is 2 samples. And we don't have the raw data. We just have the summary, like the average and the standard deviation. So you click on that, type in the average, which I forget what it was. It was 10.5. 10.5 goes here. And deviation, I think we said what did we say it was?
Mm, we never got the standard deviation.
2.3. Sample size is 25. Now, we don't want to do the hypothesis testing. What we do want is a confidence interval. Percent confidence, that compute. And the answer is 955 to 1144.
StatCrunch really does everything.
Work.
Yeah.
That's really easy. Now comes the hard part, which is the interpretation. Since the hypothesized mean, which we know is 10.5, less than, let me make sure it's right, then I'll explain. Okay. I guess before I check it, let me explain because I'm afraid I might lose it. Okay, this is the answer we got from the stat. So we're saying we're 95% sure that let me go back a little theory. Somebody did this experiment and found the average was 10.5, right? But that was just based on 25 observations of people or whatever. If you took another 25 people, you might get 10.7. If you took another 25 people, you might get 11.2. If you took another 25 people, you might get 10.3. Again, I talk about this in the videos. So just because you got one sample doesn't prove the answer is 10.5, right? It's just your estimate. Follow me?
Yes.
Okay. So we want to know, is it possible that the average is greater than 11? It's possible because maybe we've got a bunch of small people in the sample. The average really is greater. But we know that the average is somewhere between 955 and 10.44. That's what the confidence interval is saying. Is somewhere between 955 and 11.44. In other words, average of 10.5 is our particular average, but given the fact that they may be higher or lower on occasion, 5% confidence is in between here. Now we want to know, is it possible that it's bigger than 11? Well, 11.44 is bigger than 11. So we're saying it could be bigger than 11. So I was wrong here when I said is greater than, I'm sorry, less than. Give me 1 second to straighten this out. 10.45 is less values of confidence interval. I get a value of some of it. Okay, now I'm sorry. I'm a little bit, okay, now I got it straight. We're saying the average is somewhere between 955 and 1144. Okay. 10.5 translates when you do the formula for the confidence interval or StatCrunch. So we're pretty sure the average is somewhere between here and here. When I say the average, the real average, a sample is 10.5, but if you did millions of people, we're pretty sure the average will turn out to be somewhere between here and here. Sometimes it might be 10.7, sometimes 10.3, sometimes it might be as low as 10.6, or even as high as 11.4, but it's going to be between here and here 95% of the time. So somebody wants to know, is the average bigger than 11 based on 10.5? Well, again, hold on. Give me a second. Is it equal to 11? No. 10.5 is less than the upper end of the interval. That's true. And that means we do not reject it. I'm just trying to figure out how to explain it. And the guy can not reject it 0. Okay, here's another way to do it. Here's a good clear way to do it. There are two, when you do hypothesis testing, there's always only two possibilities. Either it's equal to some number, or it's different than a number, or bigger than a number, or lower than a number. But this is called a null hypothesis. We always give this like the benefit of the doubt. Like this is innocent until proven guilty. Okay. So the question is, we accept or reject that the average is really 11. All right. But we just said, based on this data and based on the formula and all this theory, that the average is somewhere between 955 and 11.44. Okay. That's after all is said and done. We believe the average is somewhere between here and here. When I say the average, I mean the mu, the average of the whole population. So 11 is right in the middle there, right? So in other words, is 11 consistent with this? Yeah. In other words, we're saying it's somewhere between 955 and 1144. So if somebody makes the claim it's 11, there's nothing wrong with that. We believe it's somewhere between here and here. So because 1055 is less than the upper end of the interval, we do not reject H0, meaning basically it's another fancy way of saying that we continue to believe the H0, that it's really 11. Does that make sense to you, or would like me to?
Yeah, it does.
Okay, so this is the answer, and hopefully I'm not going to make a fool of myself. Ah! Okay, this is greater than, is one of. Oh, well, I didn't really care. See, I didn't make a fool. Got to read things carefully. This is the choice. Since 10.5 is one of the intervals, in the interval, meaning 10.5 is in between here and here. So it's saying I just didn't. Okay, 10. Okay, so this is the answer. Ah! No way. One second. Right, 1 second. 10.5 less than. Okay, again, I deserve to get it wrong, but I think this is no. Okay, I know the theory. I know the theory, but this really does make sense. I don't have to explain it now, because if this was what a typical, or what's called a two-tailed test, mu equals 11 or mu is not equal to 11, then my answer is right. But we're trying to prove that it's bigger than 11. What we're saying is we're really focusing only on one side. Is the average greater than 11? I don't care about in the middle between the two numbers. That would make sense if we're comparing it equal versus not equal. But since the example is one of those examples in chapter 13 was called a one-tailed test or a directional test, we want to know, is it 11 or bigger than 11? Well, 10.55, we're saying the highest it could be is 11.44. Right? So we're saying, and 10.5 is I'm sorry, try it again. 11 is less than. Okay, I made two mistakes. Okay. It's possible I'm going to make a fourth mistake right now. The 10 point, again, I'm not reading it carefully. I don't know why I'm really screwing this. I apologize. It's confusing me. The hypothesized mean, that's the 11. Remember, the hypothesis is called the hypothesized mean as opposed to the sample mean, which is the actual mean. So the 11 belongs here. That's the first mistake I made. Another mistake. And 11 is less than the value contained in the confidence interval. I'm going to go back to this one now. It's one of the values. Do not reject at zero. Now, possible I made another mistake. That's right. So again, so first of all, this was a careless mistake because they want the hypothesis mean of 11 is one of the values contained in anything. That goes back to my original interpretation. 11 is if